Hey guys, today we're going to talk about evolution. It's probably one of the most misunderstood concepts in all of science. This image that I drew, how poorly drawn it is, I do realize I am not an artist, never claimed to be, but we've all seen this image of an ape slowly progressing into a man. A lot of the funny photos will have a man wearing a tie, going to work, maybe holding a briefcase. And I think this leads my students to make the assumption that an ape turned into a man. And that idea is absolutely flawed. An ape did not turn into a man. An ape did not will himself to become a man. A current day ape did not evolve into a man. You see, a long time ago, there was primates. And these primates, through one of the main driving forces of evolution, called natural selection, caused these apes to change gradually over time. These apes are not the same apes that exist today. These are apes that existed a very, very long time ago. And natural selection is the idea that species have way more babies than they should. And among these babies, there's variation. Variation in the way that they look, variation in the way that they act, variation in the length of their fur, and how big their ears are, and how tall they are, and how strong their bones are. Their genetic makeup is altered. Things that you can see, things that you cannot see. And some of these variations have really no implication on allowing an individual to survive to an age in which they can reproduce. But some of these variations are a very, very, very big deal. And the more pressure that you put on a population, the more these differences in variation will stand out. If I could give you an example, let's imagine for a moment that we had a population of, well, let's use the most commonly referred to example in biology textbooks, which is probably the peppered moth. So if we look at a peppered moth, and we consider the fact that a peppered moth existed in England prior to the Industrial Revolution. Many of the trees in England are very similar to our beech and birch trees here in North America, where the trunks are white in color and very smooth in texture. Let's make it autumn, and we'll say that this tree is red. But the bark of this tree is a white in color. And so when these peppered moths are generally white prior to the Industrial Revolution, they land on the trunks of these trees, or they land on the branches of these trees, and they have camouflage. And so little birds, or big birds in this case, who are searching to eat them, have difficult time finding them. However, during the Industrial Revolution, a lot of soot and ash and fallout occurred. And it turned these trees to be a darker color. And when these trees became a darker color, these birds had a much easier time locating the moths. But lucky for the moths, their survival technique, like all insects, is to have an overabundance of offspring, which creates great variation. And among that variation, many things occur, such as mutations. And these mutations lead to differences in size, differences in wing shape and texture, color patterns, antenna lengths. Some of these variations have no impact on this new pressure that's being put on the population. The population is receiving this new pressure because now there's all this pollution in the air, and the trees are changing color, and now all of a sudden it's very advantageous to have speckles. To have a mutation which changes the pigment of your color, making it much more difficult for you to be seen by the birds, thus increasing your likelihood of survival. And if you're more likely to survive, then you're more likely to reproduce. This is the idea of natural selection. It hinges on the idea that there is a variation among individuals and that individuals are not identical to each other, and there is a genetic difference that exists among individuals. And science has absolutely proven that. Natural selection. Natural selection is not random. Natural selection is driven. It's driven by pressures that exist in an environment. It's driven by changes in those pressures, changes in the environment, and it is going to favor the things that enhance survival, thus increasing the chance that the individual will reproduce. These changes, I'll hear science teachers say that these changes happen over very long periods of time, but that's not always the case. These changes can happen over very short periods of time if the reproductive rate is fast. Organisms such as bacteria have very, very, very fast reproductive rates in comparison to that of mammals. So mammals are going to evolve at a much slower rate than bacteria. You hear people say that if there was a nuclear war that broke out and that organisms were wiped off the planet, or that a tremendous amount of pressure because of changes in the environment were placed onto all of these different populations, that one of the only ones to survive would be bacteria. And one of the reasons that that theory exists is because bacteria has such a short reproductive rate. Generation after generation after generation can happen in a very short period of time. Therefore, adaptations, natural selection, can happen over a much shorter period of time than in mammals. But not everything that controls evolution is actually random. Or, I'm sorry, not everything that controls evolution is a non-random act. Randomness has a place in evolution. So natural selection actually shapes organisms. It designs them. The premise is that organisms will always struggle to survive and reproduce. That's what life is. It's a struggle. And organisms will produce more offspring than can survive. It is an absolute necessity in all organisms. There are individuals that die. This eliminates the genetic variation that is not beneficial to the species. Now, I am by no means advocating this with humans. But when we look at the natural world, we have to understand that offspring dying at young ages before reproduction is an absolute necessity. Why is there variation among species or individuals of species? It's because the genetic makeup is different, and the environment that they're being exposed to is different. Some of these individuals are going to be much better suited for their environment, and as a result, they're going to reproduce more effectively. Natural selection is an act that works on genetic variation. But is it the only thing that acts on genetic variation? There's an idea called genetic drift. And if you've ever played the game of war, the card game of war, you understand genetic drift. Acts of randomness, randomly placing two cards against each other and taking the one with a higher value to take the other card. Sometimes the deck gets very lopsided. Even if the deck were split evenly between the two people that were playing war, there still is going to sometime be a winner. These acts that are happening when you play war are absolutely random. And if we look at alleles of genes in the same way, we understand that randomness does play a role. Adaptations are processes over time where the characteristics lead to better reproductive success. These are individuals that become most adapted or best suited for their environment. And as a result, they become the most prevalent ones in a population. Random acts of mutation can occur in DNA, which causes genetic variation among individuals. And that genetic variation that changes in these mutations, it gets passed on to the next generation. Only gets passed on if it doesn't negatively impact the individual. If it negatively impacts the individual, it makes them less likely to survive until they can reproduce. And that mutation gets wiped out. But if the mutation is beneficial and it makes them more likely to live until they reproduce, it makes them more likely to pass that same mutation on to the next generation. These mutations are accidental. That's inferring that they are random. And if a good random mutation happens to an individual, and it makes them much more likely to survive in their environment, it means that mutation is very likely to get passed on to the next generation, and the next generation, and the next generation. And we would expect that mutation to increase in the overall percentage of the population. Now there's 3 different selection methods of natural selection and genetic variation. There's something called directional selection. This is the idea that there's one thing that will favor a population or individuals in a population. So this example that you see on this slide is talking about mollusks, and mollusks have shells. If an environment favors thick shells, and there's way more individuals over time that have thick shells, this would be called directional selection. A stabilizing selection means that the intermediate traits are going to be favored. So the status quo, the average height, the average thickness of shell, the average whatever characteristic we're talking about. If the environment favors that, we would call it intermediate traits or stabilizing selection. The bulk of the population is going to contain that characteristic. But sometimes we have something called disruptive selection, which basically it gives the impression that an environment could favor something that's really small or an individual that's really large. But the individuals that are in between, they don't seem to do as well in the environment. This example is saying that if a mollusk has a really thin shell, then it's a positive thing, and if it has a really thick shell, it's a positive thing. This is called disruptive selection. So basically what's going to happen is these traits are going to move in opposite directions of each other. And eventually we won't have any that fall in the middle, but we will have a bunch that fall on the outside. So what does the environmental conditions do? The environmental conditions are the things that apply the pressure to a population. The greater the pressure, the faster the organism has or is going to change. The only alternative to that is if the pressure is so great, the organism could become extinct. There's selective pressures that influence adaptation. Related species that are in different environments are going to experience different pressures. And over enough time, they should evolve into different species. And that's called divergent evolution, when things divert or separate from themselves. But then we have something else called convergent evolution. And convergent evolution is the idea that we could have two totally separate species that end up looking very, very similar to each other, like a dolphin and a shark. They're unrelated. They came from different branches of the tree of life. But they have converged to look very similar to each other because their environment is so similar. Nature designs these perfect organisms, or nearly perfect organisms, that perfectly fit their environment. And so it makes sense that two separate species could eventually evolve to look very similar to each other.